In this problem, we kick a soccer ball at 45 degrees at 25 meters per second and try and get it over a wall that is, or a fence that is 3.0 meters tall, 22 meters away. And the problem asks us to figure out how far above the fence it goes over the fence, or if it hits the fence, how much higher would it have to be to get over the fence. So the first thing to do is set our positive directions. Up is positive y, to the right is positive x for my problem. So I'm going to break up my 25 meters per second into x component and y component. So 25 meters per second times the cosine of 45 degrees gives me 17.6 meters per second. The velocity initially in the y is 25 meters per second sine 45 degrees. That also gives me 17.6 meters per second. I know my acceleration in the y direction is negative 9.81 meters per second squared. I know the distance it's going to move in the x direction before it gets to the fence is 22 meters. I'm not going to include that 3 meters in my dy because I'm not going to say that the ball will definitely end up going to the top of that fence. It might go way over it, it might not reach to it, and maybe under 3 meters. So I don't know what dy is. In fact, I'm going to try and find out what dy is. And if it's more than 3 meters, I can say it went over the fence. And if it's less than 3 meters, I can say it hit the fence. I would like to find time. And sometimes we say Vf in the y direction is 0. But we know that that occurs at the top of its path. And we have no way of guaranteeing that the ball will be at the top of its path when it passes the fence. It may still be going up. It may be on its way down. We don't know. So this is all the given information I know. So to solve for time, I'm going to use the x information. So now I know that the ball will get to the plane of the fence 1.25 seconds after it's kicked. Now I want to figure out how high up it is 1.25 seconds into its flight. So I'll use d equals vi t plus 1/2 a t squared. Plug it into the calculator. 17.6 times 1.25 plus 0.5 times negative 9.81 times 1.25 squared. And I get 14.3 meters. So that means the ball is way up here, 14.3 meters above the ground, above the level it was kicked from. My question, be careful, was how far above the fence is it when it goes over the fence? So I'll subtract the 3 meters tall that the fence is, and the answer to the problem is that the ball passes 11.3 meters above the fence.